Hey y'all, it's me, Amanda. Today I'm unlocking Chapter 7 of C++, Namespaces, Strings, and more. We're diving deep into some user-defined data types, namespaces, and the string type. First up, please hit the like button, leave a comment, and subscribe to the channel. If you do not have a YouTube account, you can create one free, and it takes less than a minute. Now let's start with enumeration types. Enums let you define a variable that can only have one out of a small set of possible values. For example, you can create an enum for days of the week, and it'll only accept values like Monday, Tuesday, etc. It's a handy way to make your code more readable and error-free. Once a data type is defined, you can declare variables of that type. The syntax for declaring variables of an enum type is the same as before. Data type identifier, the statement, enum sports, basketball, football, hockey, baseball, soccer, volleyball, defines an enumeration type called sports. The statement, sports popular sport, my sport, declares popular sport and my sport to be variables of type sports. Once a variable is declared, you can store values in it. Assuming the previous declaration, the statement, popular sport equals sign football, stores football in popular sport. The statement, my sport equals sign popular sport, copies the value of popular sport into my sport. This little gem allows you to create a new name for an existing type. The typedef statement does not create any new data type. It creates only an alias to an existing data type. No arithmetic operations are allowed on the enumeration type. Suppose you want to increment the value of popular sport by 1. When the type name is used, the compiler assumes that the user understands what he or she is doing. It's a huge time saver, trust me. Because an enumeration is an ordered set of values, the relational operators can be used with the enumeration type. Recall that the enumeration type is an integral type and that, using the cast operator, that is, type name, you can increment and compare the values of the enumeration type. Therefore, you can use these enumeration types in loops. Using enumeration types in loops increases the readability of the program. Because input and output are defined only for built-in data types such as int, char, double, and so on, the enumeration type can be neither input nor output directly. However, you can input and output enumeration indirectly. The values that you specify for an enumeration type must be identifiers. You can pass the enumeration type as a parameter to functions just like any other simple data type, that is, by either value or reference. Also, just like any other simple data type, a function can return a value of the enumeration type. Using this facility, you can use functions to input and output enumeration types. The enumeration type is an integral type. In previous sections, you first defined an enumeration type and then declared variables of that type. C++ allows you to combine these two steps into one. That is, you can declare variables of an enumeration type when you define an enumeration type. You can use the cast operator to increment or decrement the value of an enumeration type. A data type wherein you directly specify values in the variable declaration with no type name is called an anonymous type. Even though these facilities are available, use them with care. To avoid confusion, first define an enumeration type and then declare the variables. The syntax for an enumeration type is enum type name, value 1, value 2. So there you have it, enumeration type in a nutshell. Now let's explore the next topic. Right after this. In July 1998, ANSI ISO standard C++ was officially approved. Most recent compilers are also compatible with ANSI ISO standard C++. To be absolutely sure, check your compiler's documentation. The two standards, standard C++ and ANSI ISO standard C++, are virtually the same. The ANSI ISO standard C++ language has some features that are not available in standard C++, which the remainder of this chapter addresses. In subsequent chapters, unless specified otherwise, the C++ syntax applies to both standards. First, we discuss the namespace mechanism of the ANSI ISO standard C++, which was introduced in Chapter 2. A using statement is typically placed directly after the namespace declaration. When a header file, such as IOStream, is included in a program, the global identifiers in the header file also become the global identifiers in the program. Therefore, if a global identifier in a program has the same name as one of the global identifiers in the header file, The compiler generates a syntax error, such as identifier redefined. The same problem can occur if a program uses third-party libraries. To overcome this problem, third-party vendors begin their global identifiers with a special symbol. Namespaces help avoid name conflicts in large projects by grouping entities like classes, objects, and functions under a name. Think of it as a way to keep your code neat and tidy. If you're using ANSI ISO standards, you'll often see namespaces like for standard library functions. Speaking of the standard library, let's chat about the string type. The class in C++ is a powerful tool for handling text. You can easily perform operations like concatenation, comparison, and searching. The scope of a namespace is local to the namespace. The identifiers in the system-provided header files, cmath and iomanib, are defined in the namespace std. For this reason, to simplify the accessing of identifiers from these header files, we have been using the following statement in the programs that we write, using namespace std. You can simplify the accessing of namespace members with the using statement. There you have it, namespaces in C++ programming. Now let's move on to the next section, right after this. In Chapter 2, you were introduced to the data type string. You can access an individual character within a string using the array subscript operator together with the position of the character in the string. Recall that prior to the ANSI ISO C++ language standard, the standard C++ library did not provide a string data type. In C++, it's called the array subscript operator. Compiler vendors often supplied their own programmer-defined string type, and the syntax and semantics of string operations often varied from vendor to vendor. The position of the first character in a string starts at 0. The data type string is a programmer-defined type and is not part of the C++ language. The C++ standard library supplies it. Before using the data type string, the program must include the header file string as follows. #include Chapter 3 discussed I/O operations on the string type. Chapter 4 explained relational operations on the string type. Resize is not a string function. We recommend that you revisit Chapters 3 and 4 and review the I/O and relational operations on the string type. Other operators, such as the binary operator plus, to allow the string concatenation operation, and the array index subscript operator, have also been defined for the data type string. The erase function is used to delete all of the characters in a string. Well, that is a wrap for string type. Thanks for watching. Please hit the like button, leave a comment, and subscribe to the channel. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Now you are ready to jump into Chapter 7 programming exercises. Good luck, and I hope to see you on the next one.